Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance, and today we will be discussing how to determine the ionic formula given the name of the ionic compound. So in this particular case, we're given the ionic compound as being magnesium chloride. And from here, we can determine all the species involved in this compound. We know magnesium from the first one, and the second one is chloride. And if you know your work from reading up on ionic formulas, you know that the second species always ends in an IDE. So if you were to remove the IDE, you can readily determine that the chloride actually stands for chlorine. So we're given that we have magnesium and chlorine. Those are our two species. Well, magnesium is in group 2. And every species in group 2, which is the column on the periodic table, has a +2 charge, sometimes written as 2+ in your book. So I'm going to be consistent on that. Chlorine is in group 7. And every species in group 7 has a -1 charge, and your book writes it as just a minus. So in looking at our ionic formula, we have to recognize that the charges should cancel each other out. The long form way of doing this, if it's complicated for you, is to recognize that 2, which is the charge on magnesium, -1, which is the charge on chlorine, plus some unknown value has to equal 0. Well, if you combine like terms, you find that 1 plus the unknown value is equal to 0, and then you just subtract 1 to both sides. And you find out that your unknown value has to be -1. So it's fairly simple in this case, but that basically means that our charge should be a -1. Well, we can note that chlorine has a -1 charge. So our new value, our new formula, will actually have 2 chlorines per every magnesium. So when we write the formula out, we see that we have 2 magnesiums with a 2+ plus 2 chlorines with a minus. The charges will cancel each other out, and the coefficient will drop down to the subscript when you put the ionic formula together. And so our final formula will be magnesium chloride as written MgCl2. Please note that this is in its empirical form. You always write ionic formulas in their empirical form, and that is due to the fact that they do dissociate in solution. And that is all there is to it to ionic formulas. The same process can be applied to any ionic formula where you're given the name of the formula. And likewise, if you're given the formula, the chemical equation for the ionic formula, then you can find the ionic compound's name simply by working in reverse and determining that magnesium is the cation and chloride is the anion. Cation being your positively charged ion, and anion being your negatively charged ion. The anion always comes second, the cation always comes first.